Welcome to Manifested Publishers.
Hello students, welcome to today's lesson. My name is Dickens Mugalo, and in today's lesson we want to learn about the preparation as well as the physical properties of alkanes. Now remember we said alkanes belong to a group of, they form homologous series, and we gave the properties of homologous series. One of them was that the fact that compounds that form homologous series have a general method of preparation. So the same thing applies to alkanes. There is a general way in which alkanes can be obtained from general products. So we are going to start by using methane as our example. So laboratory preparation of methane. So we start with methane, and then we shall give a general method of preparation. So methane is prepared in the laboratory by reaction between soda lime. Soda lime is actually a mixture of sodium hydroxide and calcium oxide, though the sodium hydroxide plays a major role in that particular reaction. So it's a mixture of sodium hydroxide and calcium oxide. So we are saying that methane is prepared by reaction between soda lime and sodium ethanoate. Sodium ethanoate is just an organic, the salt of an organic acid. And that organic acid is obtained from ethanoic acid. We shall see that one later in organic chemistry 2. So the reaction between ethanoic acid and sodium gives you sodium ethanoate. So the formula of sodium ethanoate is as follows. From this prefix ether, it means we have two carbon atoms. So the formula is as follows. We have CH3, then we have COONA. So that is how we write the formula of sodium ethanoate. So my dear student, we are saying that for us to obtain methane, you simply carry out the reaction between soda lime and sodium ethanoate. So the diagram is arranged as follows. So the setup in preparation of methane is as follows. So it's good we look at the diagram for the sake of exam purposes. So the first part of the diagram is we have a round bottomed flask. This round bottom flask has been set in a slanting position, and then we have the stand just to hold that round bottom flask in position. So we have our stand here just to hold this flask in position, and then we put the mixture of soda lime and sodium ethanoate in this round bottom flask of ours, and then we heat. You heat. So here we have a mixture of the two. So this is a mixture of soda lime and sodium ethanoate. So the two are put together in that round bottom flask, which is then heated. During heating, we have products. We are going to see the products that are formed as a result of heating. So we have this. So we have our delivery tube. That delivery tube is connected to the normal beehive shelf, and the mixture, of course, the the beehive shell is put in just under a gas jar, the gas jar where we shall collect the gas. And then below we have our basin. So we have this as our gas jar. This is our gas jar here, where the gas will be collected. So already you should be able to tell one physical property of methane is that the gas is slightly soluble in water, and that's why it is collected over water. You can see this method of collection, we call it over water. So we have, these are bubbles of the gas. So the normal setup that we use in collecting the other apparatus. So in the round bottom flask is where the two compounds are heated. When they are heated, we shall have two products, and one of the products is methane, the gas. So the gas will flow through this delivery tube, and then it will be collected over water. So here we shall have our methane gas, which will be collected by the indication of the fact that the level of the water will move downwards so that the gas will be collected. So this is the normal water. And then we have our beehive shelf. Beehive shelf, the normal one. And then this is our gas jar. And then this is our normal trough. So these are just the normal apparatus for collecting gases. So it's good we draw the diagram for exam purposes. So you can see on the left part, we have our round bottom flask. Of course, we use round bottom because for round bottom flask, there is equal distribution of heat. So the reaction takes place in the round bottom flask where methane gas is evolved. So the reaction is as follows. So the reaction in the flask. Now, remember we have said in the flask, there is the reaction between soda lime and sodium ethanoate. So the sodium hydroxide is the main component that is going to react with the sodium ethanoate. So the reaction is as follows. So reaction between sodium hydroxide and sodium ethanoate. Sodium ethanoate, soda lime and sodium ethanoate. The two react, we get methane gas as it's going to be to move through this delivery tube. Then the other product is sodium carbonate. Sodium carbonate, that is the other product that is formed. So that is the reaction that takes place in the conical flask, and the reaction occurs in the presence of heat. So anytime you write an equation, always try to balance. So let us check. On the left hand side, we have 2 sodium atoms. On the right hand side, there are 2. On the left hand side, we have 1, 2, 3 oxygen atoms. On the right, there are also 3. And then hydrogen atoms, this is 1 plus 3, 4. We also have 4 hydrogen atoms on the right. And then lastly is carbon atoms. This is 1, 2, 2 on the left, then 1, 2, 2 on the right. So that is the reaction that will evolve methane gas. So it's the reaction between sodium hydroxide and sodium ethanoate. Sodium ethanoate. So I want us to look at other reactions that will produce alkanes. So the next reaction is the reaction that will produce ethane. As you know, ethane contains 2 carbon atoms. Now, the difference will come here. The soda lime will be the same, but what will be different will be this organic salt. So, instead of sodium ethanoate, we now use that organic salt that has 3 carbon atoms, and that organic salt is called sodium propanoate. So, For us to prepare ethane, we use sodium propanoate. So the reaction is as follows. Preparation of ethane. The reaction, we have seen ethane has 2 carbon atoms. The organic salt we use will now have 3 carbon atoms. So the reaction will be as follows. Sodium hydroxide will react now with the sodium ethanoate. So ethanoate has 3 carbon atoms. So these are right sodium ethanoate. This is CH3. Then we have CH2, and then we have COONA. We have 3 carbon atoms. 1, 2, 3. So this one is called sodium propanoate. Yes, it's sodium propanoate. Sodium propanoate because it has 3 carbon atoms. The one that has 2 is called sodium ethanoate. So the reaction occurs, of course, in the presence of heat. The product will be ethane. The formula is C2H6, and the other product will be the same, sodium carbonate. So state symbols: solid, this one is liquid or aqueous, then gas, and then solid. Balancing, if you check the equation, it's balanced. So we are saying for us to get ethane, we use sodium propanoate. Suppose you want to get the next one, preparation of propane. Remember, propane has 3 carbon atoms. Therefore, the salt we use will have a total of 4 carbon atoms, the organic salt. So the name of the organic salt will now be sodium butanoate. You add 1 carbon atom to the organic salt. So the sodium hydroxide remains, soda lime. So sodium hydroxide plus the name of the organic salt is now having 4 carbon atoms. So this part remains CH3, and then you have CH2, and then COONA. This one has 1, 2, 3, 4 carbon atoms. So this organic salt is called sodium butanoate. From the name butane, butane has 4 carbon atoms. Therefore, the organic salt will be butanoate. So butanoate is used to prepare propane. So the reaction occurs in the presence of heat once again. So the product will be propane, which is C3H8, and then plus the other common product, which is sodium carbonate. And the process continues on like that. Remember, we said compounds which form homologous series have a general method of preparation. You can see the general preparation is what? You react. So generally, if you want to prepare an alkane, you react sodium hydroxide and sodium alkanoate, or the organic salt, alkanoate, and that will give you the alkane, and then plus sodium carbonate. So that's why we said homologous series have a general method of preparation. So as far as alkanes are concerned, if you want to prepare an alkane, you react sodium hydroxide with an organic salt that contains sodium, you'll get an alkane plus sodium carbonate. So for that matter, if you want to prepare, the next member is called butane, you simply react sodium hydroxide and that alkanoate that has 5 now. The one that has 5 is called sodium pentanoate. It will give you butane plus sodium carbonate. So those are the, or that is the general method of preparation of alkanes. So having said that, I would like us to look at now we mentioned the physical properties of alkanes. We have already seen from the preparation, we prepare alkanes by simply reacting the appropriate alkanoid and soda lime. And remember, soda lime, the main part of that mixture that will react will be sodium hydroxide. So I want us to look at the properties. So below is a summary. Of some physical properties of alkanes. So we have a summary of some physical properties of alkanes. The summary is in the form of a table. So we shall look at the table and then we discuss those properties as we move on. So the first column of our table, we shall put the number of carbon atoms. So here we have carbon atoms. So this is carbon atoms. Then we have the formula. We have the formula. Then we have the name. We have the name. And then from the name, we shall have the state at room temperature. State at room temperature. Then the next column, we shall have melting point. The melting point is in Kelvin. Then the second last column, we shall have our boiling point. Then lastly is density in grams per centimeter cubed. So this table will give us the properties of these alkanes. So when the number of carbon atoms is 1, that alkane has the following formula, CH4. Its name is methane. I believe by now we know methane. State at room temperature, state means either gas, solid or liquid. So methane is a gas at room temperature. It has a melting point of 90 Kelvin and a boiling point of 112. Density 0.424 grams per centimeter cubed. Carbon atoms 2, formula C2H6. The compound is called ethane. State at room temperature, it's a gas once again. Melting point 91, boiling point 184, density 0.546. You can see the first two, the trend in terms of melting point, boiling point, as well as density. The next one, carbon atoms 3, formula is C3H8. The name is propane. State at room temperature, gas. Melting point is around 85. Then boiling point 231. Then density 0.501 grams per centimeter cubed. Then carbon atoms 4, formula C4H10. The name is butane. State at room temperature, this one is also a gas. Melting point 138 Kelvin. Boiling point 273. Density 0.579. So generally by now you should be able to see the trend. Generally boiling and melting point are increasing. That's the general trend. Carbon atoms 5, formula C5H12. The name is pentane. I believe we know that. This one is now liquid at room temperature. That's now the state. Melting point is 143 Kelvin. boiling point 309, density 0.626. Once again, the density is increasing gradually as you move down the series. 6 carbon atoms, formula C6H14, name is hexane, state at room temperature, liquid, boiling point 178, melting point 178, boiling point 342, density 0.657, carbon atom 7, formula C7H16, the name is heptane. I believe by now we know. State at room temperature, liquid, melting point 182 Kelvin, boiling point 372, density 0.684. Carbon atoms 8, formula C8H18. The name we know, it is called octane. State at room temperature is when you have a liquid. Then the melting point is 216 Kelvin. Boiling point is 399 Kelvin. Density is 0.703. Then carbon atoms 9, formula C9H20. The name is nonane. Remember the prefix and the suffix should be different. State at room temperature, liquid. Melting point 219 Kelvin, boiling point 424, density 0.708. Then lastly is carbon 10, formula C10H22. The name is decane. State at room temperature, liquid. Melting point 243 Kelvin, boiling point 447 Kelvin, density 0.730. So as you can see from this table, my dear student, there is a gradual increase in both melting and boiling point from methane up to decane. So melting point increases, boiling point also increases, as well as the density. So these three are attributed to the fact that there is increase in the number of carbon atoms. You can see the number of carbon atoms are increasing from carbon 1 all the way up to carbon 10. So that alkane with one carbon atom will have a lower melting point than alkane with 10 carbon atoms, which will have a higher melting point. So the number of carbon atoms results into an increase in molecular mass, and that will make that particular alkane to have a higher melting and boiling point. So generally we are saying one of the physical properties is that there is increase in melting and boiling point down the group. That is the first physical property. Then the next physical property is that the density also increases down the group due to increase in molecular mass. Then state at room temperature, you can see the first 4 alkanes are gases. Then the next 6 are liquids. Somebody might wonder, what about those which have more than 10 carbon atoms? So those alkanes with more than 10 carbon atoms are solids. So this is now the property that I'm talking about, that the first 4 alkanes are gases. The next 6 alkanes are liquids. Then the rest are solids at room temperature. So we can just note that one. So we are saying that melting point and boiling point increases down the series due to increase in number of carbon atoms. So the number of carbon atoms will result into an increase in melting and boiling point due to increase in molecular mass. The same can be attributed to density. Density also increases down the series due to increase in molecular mass. I believe from what we learned earlier in the topic, mole should be able to get molecular mass. For example, the molecular mass of methane is obtained by adding the relative atomic mass of carbon, which is 12, plus the relative atomic mass of hydrogen, which is 1, and we have 4 atoms. So you take 1 times 4, that will give you 4, then you add 12. So the molecular mass, e.g., molecular mass of ethane, not really ethane, but methane is, you take 12 plus 4, that will give you 16, while that of, say, pentane is, so we get the molecular mass of pentane, you take the relative atomic mass of carbon, which is 12, you multiply by 5, that will give you 60. Then you add the RAM of hydrogen, which is 1, times 12. So it is 12 plus 60, and that will give you 72. So you can see the fact that pentane has a molecular mass of 72, while methane has a molecular mass of 16. You can see 72 is greater than 16. Therefore, you expect pentane to have a higher density. In terms of states at room temperature, the first 4 alkanes are gases. Then next 6, that is pentane all the way up to decane, are liquids, while the rest are solids at room temperature. Then lastly is about solubility. It's good you also mention it. From the setup of the diagram for preparation, we can say that they are slightly soluble in water. But when it comes to organic solvents, of course, water is inorganic. Organic solvents are things like carbon sulfide. So alkanes are very soluble in organic solvents, but slightly soluble in water. So that's another physical property, very soluble in organic solvents, such as we have methylbenzene. This is an example of an organic solvent, and carbon sulfide. So in terms of solubility, we are saying that alkanes are very soluble in organic solvents. So in terms of the comparison of solubility, as you move down the group or the series we have seen, there is change of state from gas to liquid and then to solid. So in terms of solubility, you will realize that as you move down the series, as the number of carbon atoms increases, the solubility decreases. So I rejoined a point is that but solubility decreases. Solubility decreases down the series. So these are the main physical properties of alkanes. So we have come to the end of our lesson. To wind up that part, I would like you to try and answer the following questions for your revision. Just try and answer these questions for your revision. to help you prepare for the exam well. So these are your questions which I would like you to try for this particular lesson. Our first question is give the general method of preparing alkanes. Question number 1 is we are required to give the general method of preparing alkanes. Our second question, which I would like you to try, is write an equation to show the preparation of hexane. Question number 2, write an equation to show how hexane is prepared. Third and final question is state 3 physical properties. State 3 physical properties of alkanes. State that question. State 3 physical properties of alkanes. So, my dear student, that is the end of our lesson. I want to thank you for being a good student, and I'll see you in our next lesson. Thank you so much.